Hello, class. Today we are going to be moving on to solving systems of equations, linear and nonlinear systems of equations. So everything that we've been doing up to this point has been linear of some form, two equations, two unknowns, or three equations with three unknowns. But now we're going to be moving on to what if we have a parabola? Where would the line cross? What points would they have in common? What if we have a circle in a parabola or two parabolas crossing? So we're looking for those intersections. We're going to be looking a little bit with Desmos, and likewise we're going to be working with just remembering how to graph some of the basics. So in the first one over here, we're going to try to do our best by remembering how to graph these and solving them algebraically. Really, the main component is going to be the algebraic solving of each one of these, but we still want to be able to use our resources to check our work and be very familiar with knowing how to put these into your Desmos graphing calculator. All right, so let's go ahead and let's go through some of these, and let's start with the first one. Over here, what you see is an x squared plus y equals 9 and y equals x plus 3. So the first one is a parabola and the second one is a line. So let's go ahead and let's solve this system first algebraically, and then we're going to go ahead and proceed to graph and check our work to see if it makes sense. All right, so the process of graphing, you can I would recommend solving for one of the variables and substituting it into the other equation. And this one is actually beautifully set up because one of the variables in one of the equations has already been solved for. So I can use the method of substitution, simply taking what y is, putting it into the other equation, and consolidating, and then again looking to see what their intersection is. Okay, all right, so let's go ahead and do this process of substitution. So I'm going to take this right here, showing my work. All right, so this equation ends up, I will rewrite it down below. I end up with an x squared plus x plus 3 is equal to 9. And then from there, simplifying, and notice that you have a quadratic now, all in terms of one variable. I'm going to bring that 9 to the left-hand sides, and you're going to end up with 3 minus 9 is a negative 6. Try to do this as much as you can without a calculator. All right, now remember, when you're solving a quadratic, you should have two solutions here. All right, so I'm going to proceed to factor. Yes, you do need to remember how to factor. All right, what two numbers multiplied together, give you the first term, and that goes here and here. All right, and then what two numbers multiplied together will give you negative 6, but will add to the middle term. All right, so you're going to go through all the factors. Is it a 1 and a 5? Well, I know 1 times 6. 1 times 6, if you add a 1 and a 6, you get a 7, but if you subtract, you get a 5, and that is not the middle number. All right, so what about another set of numbers when multiplied together? We know that 3 times 2 is 6, and if you want to make sure that one is negative and one is positive. Now, if you add those up, is there any combination with the signs that would give you a positive 1? And you would see that a positive 3 and a negative 2 would work. Just double check, foil it out in your head, and double check it. All right, so once you get there, now we can do the zero product property. All right, so if two things multiplied together equal 0, then that means that either the first factor must be 0 or the second factor must be 0. What are the values of x that will yield 0? So for the first one, you would end up with x is equal to negative 3 will make that first factor 0, and for the other one, x is equal to 2 would make that equaling 0. Once you have now found the two values for x, now you can proceed to substitute x back into, and really doesn't matter, either of the two equations, and you probably want to go into the easier one. So I take these and I'm going to substitute it into y is equal to x plus 3, and I'm going to substitute x in for each one of those. Okay, And for the first one, you get y is equal to, plugging -3 in, you get a -3 plus 3, so y is equal to 0. And then for the second one, I'll just draw little arrows showing that we do have to put it into both. And y is equal to 2 plus 3 for a grand total of y is equal to 5. All right, so at this point, what we have is two solutions. We can put this all together. So when x was -3, y is 0, and when x was a 2, y is equal to 5. So algebraically, this is the intersection of our parabola and our line. So let's go ahead and let's confirm this. Let's go ahead and graph them. All right, so let's start with the line. All right, so we know that the equation, the line, this is already in y equals mx plus b form. 3 is your y-intercept, so that's your b value. So I'm going to go up to 3. It has a slope of 1 to 1. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. And then down 1, over 1, down 1, over 1, down 1, over 1, and so on. And here's my line. And a little crooked, we'll adjust that. And it is a line, so I am going to put arrowheads. And keep in mind, it is a positive slope. And now we're going to go ahead and we are going to graph our parabola. And part of my parabola is going to be off the page, but that's okay. All right, so this is going to be the parabola. And I'm going to take this and we're going to go back and we're going to go down memory lane and we're going to go ahead and graph this. Any method that you want to graph it that you recall from the past, but this is y. Always solve for y. You get a negative x squared plus 9. Okay, now if you remember over here, this is when you don't have that middle term in the very center. This is going to be your y-intercept. Think about it. When x is 0, what is y? And you're going to end way up here at, let's see, 6, 7, 8, 9. It's not way up here, but it's over here. So if we were to extend this, this is 9. All right, and then there's multiple ways that we can graph this as well. We can start plugging values in, making an XY table if you want. And we can do that if you want to do an XY table. There's nothing wrong with that. We can find our zeros as well. All right, if you were to let y equal 0, what would be the x value? Okay, so and you can plug that into the first one, and we will do that as well. I'm going to do that with you as well. But for right now, we can start with some basic numbers. What if you put 1 in for x? What would y equal? Now, you're not going to get a whole number there. Sometimes you're going to get square roots, but it gives us at least an estimate, I suppose. So if you were to put, we did the first one, when x is 0, you have y is 9. If x was 1, you would end up with 8. Okay, so for your y value, okay, so when x was 1, y is 8. So it's starting to come down. Now remember, these are symmetrical. So what's on one side is going to happen to the other side. When x is 2, so you have negative 2 squared. So 2 squared is 4. And then negative 4 plus 9, you get a 5 there. Let's see if we did that right. Yep. Okay. All right, so when x is 2, y is 5. Oh, we found a solution. And then 2 to the other side as well. All right, that would be another point. All right, so we're starting to get our solutions here. And you can keep going, and you can just keep adding on, going up to 3. If x is 3, you end up with 3 times 3 is 9, but it's a minus in the front, and that ends up on giving you 0. So when it is a positive 3, you get 0. But remember, it's a parabola. If I put negative 3 in there, it would be symmetrical on the other side. All right, so this is now starting to shape out. But if you notice where the parabola and the line are intersecting here, you're going to see the intersection points are negative 3, 0, and that's our algebraic solution. And over here on our line, you can see when x is 2, y is 5, check. All right, exactly the same solutions. All right, so that's the beauty of remembering how to graph. But if this is like an SAT or some other standardized test, the beauty is you would be able to use that graphing calculator. And instead of doing it algebraically, you could actually do this right on the provided calculator. Okay, but always know how to do it algebraically as well. It's nice to know. Okay. All right, in this next one over here, this is, the top one is a circle, and the bottom one, you do have another parabola, okay, because you have that x squared, and then you have the linear for the y and a constant, all right? So that is an indicator that you have a parabola. All right, and we're going to go ahead and solve this once again algebraically. So the first thing you want to do is you want to solve for one of the variables so we can substitute it into our other equation. And what I'm going to do in this one is I wouldn't solve for the first degree in this one. What I would do is watch what happens when we solve for the second degree. All right, so I can actually solve for x squared in this bottom equation. And again, there's not always a right way. Sometimes there's just a better way. So I'm going to take this equation and I'm going to solve for x squared, and I get 8y on the other side plus 104. And what I'm going to do is I'm going to take this and I'm going to substitute it in for the other equation where I see an x squared, because that is now going to give me an equation that has y squared. Oh, shush, I love her. Okay, that's my puppy dog. All right, so now we're going to go ahead and do a little substitution. All right, and you have over here, whoops, 8y plus 104 plus y squared equals 169. And let's go ahead and solve that. Now, again, you have another quadratic. It's just in terms of a different variable. It's okay. We're going to solve it exactly the same way. Go ahead and bring everything to one side, and we're going to factor once again. Y squared plus your 8y minus your 65 is equal to 0. All right, go ahead and factor. Factor equals 0. And what two numbers multiplied together give you a negative 65, but when you add them, you will get a positive 8. Well, if you notice, it ends in 5, so it's a very high chance that it's divisible by 5, and it will add up to or subtract to something that'll give you 8. So sure enough, if you take your 4-function calculator or do it off to the side, 5 goes in there 13 times. Okay, so if I take a positive 13 and a negative 5, when you take the product, you will get a negative 65, and if you add them, you'll get a positive 8. And then go ahead and set each one of these equal to 0, and you'll get y is equal to a negative 13, and y will equal a positive 5 for your two solutions. Okay, so now what we're going to do is we're going to go ahead and let's go ahead and find our other values. We're going to take that negative 13 and pick whatever equation you want to solve for. I would definitely put it into the x squared equals the 8y plus 104, because that'll at least be already set up closest to solving for x. So I'm going to do that right here. So when y is equal to, oops, let me slide it over. When y is equal to negative 13, all right, we'll go ahead and we'll do the math. I'll just do them back to back. Let me go back over here. Y is equal to negative 13. I'm going to go ahead and put it into this equation, and I get x squared is equal to 8 times negative 13 plus 104. X squared is equal to negative 104 plus 104. Negative 0. X squared is equal to 0, so that means x is equal to 0. All right, so what we have is when x is, or y is negative 13, x is 0, so we have one solution. All right, and I will write that off in a second. All right, so let's do the next one. So when y is equal to 5, let's do the same thing. Plug it in the same equation. X squared is equal to 8 times 5 plus 104. 104. And x squared is equal to 8 times 5 is 40 plus 104. X squared is equal to 144. And then you have x is equal to, now when you take the square root, you do have a plus or minus number, by the way. All right, so don't forget about that. It is a plus or minus. All right, so our solutions at the end of the day that we're going to verify, we're going to go into Desmos here in a second. We're going to go ahead and write this as you have a plus or minus 12 for the x value when y was 5, and the other one when x is 0, y is negative 13, x is 0. Sorry, I'm trying to do two things at once here. Okay, so those are your two solutions. So what I want you to do right now is I want you to go into Desmos, all right? So if you go into Google Classroom, you will be able to find the Desmos, or just pull it up on your phone. I'm hoping that you guys all have that. So let's go ahead, and I'm going to, hopefully I am not going to lose this recording. I'm a little worried about this, but we're going to give it a shot. All right, so I'm going to go into Desmos, and I'm going to type out my equations. So we're going to have, the first one is a circle. You have x to the second power plus y to the second power. So everyone should be practicing this, because again, what if this is on the SAT? All right, I do want you to be showing this and practicing. All right, so you're going to type it into the field above, and you just put your cursor back underneath it and start typing the next one. So the next one you have over here, x to the second power minus 8 times y equal to 104. Okay, so now if you don't see your graph, what you're going to want to do in Desmos is just kind of pinch it. That's it. Notice you have a parabola. All right, and I want you to now touch on the graph where you see they cross. So if you just touch the crossing spot, and if you hold it, look at negative 12, 5. Over here, positive 12, 5. And down here, 0, negative 13. Their answers are right there. So the beauty of knowing how to use these tools, especially when you're taking an SAT, they will give you the answer if you want to check your work, if you just don't want to do it algebraically and you want to use Desmos to find the solution. You just have to know how to type it in, right? And you don't have to solve for x or y and put it into y equals mx plus b form. You can put it exactly as it is. And Desmos knows how to graph it for you, right? So look, we did it right. Those are our final answers. Okay, so now let me come back over here, and if you wanted to give yourself just a, well, try your best to make a decent looking graph. All right, I'm going to make a circle. All right, and of course I'm cheating. I have this tool that is really kind of nice. It pinpoints it here, and I'm trying to remember what it looked like. Sorry, guys. I'm going to try to guess now. I know that cross down here. Green, where's the green? All right. Did this. And let's see, the circle, this is what, a 13. This is a negative 13. And the crossing point was plus or minus 12. It was something right here, over here. And it did this, and it did that. And you have down here, negative 13, 0. So there's one intersection point. And then you have your plus or minus 12 and 5. So that would be like a 5 and all the way at 12, about right here, negative 12 and a positive 12. Okay, so using tools is beautiful, again, to check your work. All right, and that's what we're going to expect you to do, is to at least check your work. Okay. Alrighty, this next one is a little bit of a doozy, but here we go. You ready? Let's try this one out. All right, so this one over here, we have, this is an S graph. All right, so remember, anything to the third degree and it's a positive coefficient, it's going to look something like this. And this one is going to be a W. It might have a squiggle or two, but the main thing is it is even, it's pointing up, and both, because it's even, we're going to be pointing up. All right, so when you go into Desmos, I'm going to ask you guys to do this one and try your hardest to get these solutions on your graph. I'm not going to graph it with you on this one, but I do want you to pinch in and I do want you to get some practice, and I'd like you to do this in groups, okay? All right, so for this problem over here, I am going to get you guys started on it, and I want you to do this and go through the process. I'll do most of it with you because I know it could be a little intimidating, but I do want you to graph it and look at it and check your work. You do have to absolutely practice this, okay? All right, so in this one over here, again, find a variable in whatever method you think is going to be best over here to solve. But what I do notice here is they both already solve for y. So I can use, if you remember, substitution method, whatever the value of y is, you can put it here. If you go back to transitive property, if y equals all of that and y equals all of that, they have to equal each other. So whatever method you want to do, that would be fine, but you end up at the end of the day, because they both equal y, that means that they are both equal to each other. Okay, so let's do this. All right, so I can set them equal to each other because they're both equal to the same thing. And I'm just going to go ahead. Don't write too big. We're going to need a lot of landscaping for this problem. Okay, and now we're going to proceed to solve. All right, I want you to notice that the 7s cancel out, so we're just going to poof those away. And just like any other problem, we're always going to bring all of our numbers to the same side of the equation and set it equal to 0, and our goal is to eventually factor. All right, so I have an x to the 4th plus, let's see, I'm going to do in descending order. I have a cube in here, so minus x cubed when I bring it to the other side, subtract 8, and I get a negative 6x squared is equal to 0. All right, now notice that each one of these has the highest degree of an x squared. So I'm always going to want to write this as a product of numbers if possible. And I notice that the highest degree can be pulled out. So I'm going to factor out my x squared, which will yield, divide all of that by x squared. What's left over is an x squared minus x minus 6 and equal to 0. You must have it set equal to 0. Bring everything to one side. And now let's go ahead and continue factoring. This trinomial will factor into what two numbers multiplied together give you a negative 6, but we'll add to a negative 1 in the middle, and that is a negative 3 and a positive 2. All right, so once you get to this point, it's all factored. You can't break it down any further. Set that equal to 0, that equal to 0, and that equals 0. So what you have here is x is equal to 0, x is equal to 3, and x is equal to a negative 2. So those are your three possible values for x. All right, and then now what you're going to do is you're going to take each one of those x values and you're going to put it into one of the two equations. I'm going to put it into the top one, okay? So I'm going to use y is equal to x cubed plus 8x squared plus 7, and I'm going to solve this for each one of them. Okay, so I'm going to start when x is equal to 0. I'm going to put it into that boxed out equation, and I end up with, whoops, what do we have? Y, hope my pen doesn't go dead on me. All right, so I have y is equal to 0 to the third power plus 8 times 0 to the second power plus 7. And that was an easy one. You probably didn't even have to show your work, but y is equal to 7. So one of the points is when x is 0, y is 7 is one of your solutions. Okay, we're going to do the same thing. This time we're going to put x is equal to 3 in. All right, so I'm running out of room here. And we get y is equal to 3 to the third power plus 8 times 3 to the second power plus 7. Y is equal to 27, not 9. Plus 8 times 3 squared is 9 plus 7, and y is equal to 27 plus 72 plus 7, 106. All right, so when x is 3, y is 106. There's your second solution. Okay, and then the last one right here, you get y is equal to a negative 2 to the third power plus 8 times negative 2 to the second power plus 7. Now be careful. Negative 2 to the third power is negative 2 times negative 2 times negative 2. 3 negatives multiplied together is a negative number. 2 times 2 times 2 is 8. And then for the next one, you have 8 times negative 2 times negative 2 is 4, and then plus 7. Simplify. Y is equal to negative 8 plus 32 plus 7. That's an ugly plus sign. Let's fix that. And then at the end of the day, we get 31. Okay. All right. So the final solution here is, for this one, is when x is a negative 2, y is a 31 for my third point. And there are 3 solutions there. Now, you really you're supposed to, at the end of the day, test the values. You have time on a test, take those values, put it into the other equation, and test all the numbers. And you don't necessarily have to do it to all 3 of them, but it doesn't hurt. All right, so it doesn't hurt to just take a second, test the values. Pick maybe the easiest one, all right? Maybe and test it into y is equal to x to the 4th plus 2x squared plus 7. Chances is, if you try it for 1 and it works, maybe just do it for the last one. 0, 7, and that might be too easy of a one, but try it. I might try this one right here. All right, test it. So when y is 31, I get negative 2 to the 4th power plus 2 times negative 2 squared plus my 7. Okay. And then I end up with 31 is equal to negative 2 times negative 2 times negative 2 times negative 2 is a positive 16 plus 2 times 4 plus 7. And 16 plus 8 plus 7, the last time I checked, is 31. So I think you're pretty safe if you just test it for 1, but you should at least test it into the second equation. Why not? It only takes a second to do, especially if you get weird numbers. We like giving you not terrible ones to work with, so it's worked out nicely. Now, I do want you to take the time. I want you to practice putting this into Desmos. I want you to pinch in on the problem until you can see. And this one's, a couple of them are little, you have to really kind of scroll through the Desmos and pinch to really see that solution, but try it. All right, change the cursors, change it, and look for that S curve, look for that W curve. It might look like a parabola, but both ends will be pointing up, and look to see if you can find it and confirm your solutions. Well, you have a great day today, you guys, and I want you to go and practice as soon as you can so you don't lose the content. Have a blessed day. Thanks. Bye-bye.